Difference between human intelligence and artificial intelligence. There is, of course, the obvious, which is that the brain is warm, wet, and wiggly, while a computer is not. But more importantly, there are structural differences between human and artificial intelligence, which I will get to in a moment. But before we can talk about this, I have to briefly tell you what artificial intelligence refers to. What goes as artificial intelligence today are neural networks. A neural network is a computer algorithm that imitates certain functions of the human brain. It contains virtual neurons that are arranged in layers, which are connected with each other. The neurons pass on information and thereby perform calculations, much like neurons in the human brain pass on information and thereby perform calculations. In the neural net, the neurons are just numbers in the code. Typically they have values between 0 and 1. The connections between the neurons also have numbers associated with them, and those are called weights. These weights tell you how much the information from one layer matters for the next layer. The values of the neurons and the weights of the connections are essentially the free parameters of the network. And by training the network you want to find those values of the parameters that minimize a certain function, called the loss function. So it's really an optimization problem that neural nets solve. In this optimization, the magic of neural nets happens through what is known as backpropagation. This means if the net gives you a result that is not particularly good, you go back and change the weights of the neurons and their connections. This is how the net can learn from failure. Again, this plasticity mimics that of the human brain. For a great introduction to neural nets, I can recommend this 20-minute video by 3 Blue 1 Brown. Having said this, here are the key differences between artificial and real intelligence. 1. Form and function. A neural net is software running on a computer. The neurons of an artificial intelligence are not physical. They are encoded in bits and strings on hard disks or silicon chips, and their physical structure looks nothing like that of actual neurons. In the human brain, in contrast, form and function go together. 2. Size. The human brain has about 100 billion neurons. Current neural nets typically have a few hundred or so. 3. Connectivity. In a neural net, each layer is usually fully connected to the previous and next layer. But the brain doesn't really have layers. It instead relies on a lot of predefined structure. Not all regions of the human brain are equally connected, and the regions are specialized for certain purposes. 4. Power consumption. The human brain is dramatically more energy efficient than any existing artificial intelligence. The brain uses around 20 watts, which is comparable to what a standard laptop uses today. But with that power, the brain handles 1,000,000 times more neurons. 5. Architecture. In a neural network, the layers are neatly ordered and are addressed one after the other. The human brain, on the other hand, does a lot of parallel processing and not in any particular order. 6. Activation potential. In the real brain, neurons either fire or don't. In a neural network, the firing is mimicked by continuous values instead, so the artificial neurons can smoothly slide from off to on, which real neurons can't. 7. Speed. The human brain is much slower than any artificially intelligent system. A standard computer performs some 10 billion operations per second. Real neurons, on the other hand, fire at a frequency of at most 1,000 times per second. 8. Learning technique. Neural networks learn by producing output, and if this output is of low performance according to the loss function, then the net responds by changing the weights of the neurons and their connections. No one knows in detail how humans learn, but that's not how it works. 9. Structure. A neural net starts from scratch every time. The human brain, on the other hand, has a lot of structure already wired into its connectivity. And it draws on models which have proved useful during evolution. 10. Precision. The human brain is much more noisy and less precise than a neural net running on a computer. This means the brain basically cannot run the same learning mechanism as a neural net. And it's probably using an entirely different mechanism. A consequence of these differences is that artificial intelligence today needs a lot of training with a lot of carefully prepared data, which is very unlike to how human intelligence works. Neural nets do not build models of the world. Instead, they learn to classify patterns, and this pattern recognition can fail with only small changes. A famous example is that you can add small amounts of noise to an image, so small amounts that your eyes will not see a difference, but an artificial intelligence system might be fooled into thinking a turtle is a rifle. Neural networks are also presently not good at generalizing what they have learned from one situation to the next, and their success very strongly depends on defining just the correct loss function. Thanks for watching video. For more interesting videos, please subscribe and like, share and comments.